Okay, so this is the key to 15.5 Part A, and on this worksheet, you're solving each radical equation, and these radicals are square roots, so notice that these are all square root equations. And this is the easier kind of square root equations. Um, so you'll notice that in each of these cases, when we do the process of solving these radical equations, we're going to end up with linear equations. So notice that we're going to go from a square root equation to a linear equation in each of these cases. Okay, now when solving a radical equation, you must first of all get it in this form. So you have the square root of a of a variable expression. All right, so you have the square root of some expression equal a number. Okay, so you need to make it look like this. All right, and then you'll see that the next step would be to raise both sides to a power that's equal to the index. So basically, we're going to square both sides. All right, so here's the idea. So in number one, I want to solve this square root equation. So I want to solve for the variable x. So what x will make this side equal to 4? That's the question. All right. So in many of these, you won't be able to guess that. And then first of all, they're asking you to show the work anyway. So you can't guess. You got to do this algebraically. So first of all, notice also that in number one, the square root is already by itself. The radical is already by itself. So all I have to do is this: to get rid of a radical expression, I raise both sides. Let me go ahead and rewrite this over. I raise both sides to a power that's equal to the index. So notice, what's that index right here? Square root, so the index is 2. So I'm going to square both sides. What I do to one side, I do to the other. Okay? And then what happens is that the square and the square root undo each other, so you're left with the radicand. So my radicand is 2x minus 1. So 2x minus 1 equals, and then 4 times 4 is 16. So notice I went from a square root equation, a radical equation, to a linear equation. And all you have to do now is solve this linear equation. So I'm going to add 1 to both sides. So I'm going to get 2x equal 17. Divide both sides by 2. And so I get x to be 17 halves. Okay? Now let's check. So at some point in another lesson, you're going to see that when you raise both sides to an even power, you do have to check. Because there are times when you will introduce what's called extraneous roots. But that's going to be in another lesson. So we're not going to talk about that in this one. So I'm going to check, and so we go back to the original. Always go back to the original. And where we see the variable x, you're going to substitute 17 halves. So let's see if this works. So I have the square root of 2 times 17 halves minus 1, and I want to see if that's going to equal 4. Well, what's 2 times 17 halves? Well, the 2's divide out, right? And so I get the square root of 17 minus 1, and again, I want to see if that's equal to 4. Well, 17 minus 1 is 16. So is the square root of 16 equal to 4? Yes. All right, so my solution is 17 halves. Okay, now what about number 2? So number 2, if you notice, is the square root by itself? No, the square root's not by itself. So before you raise both sides, before you square both sides, the square root has to be by itself. So I've got to add 4 to both sides. So then I get the square root of 3x plus 2 is equal to 5. Now I'm going to square both sides. So I'm going to square both sides now. And so when I square both sides, just like this, when you square both sides, the square and the square root undo each other, so you're left with 3x plus 2, the radicand, equal, and then 5 times 5 is 25. So notice I went from a square root equation to a linear equation. So let's solve this linear equation. So I'm going to go ahead and rewrite it over. And so I'm going to subtract 2 from both sides. So I've got to solve for x. So I get 3x equal 23. Then divide both sides by 3. I get x to be 23 thirds. All right, so if I did all this correct, then 23 thirds should be the solution, right? So let's check. So to check, you always go back to the original. So here is my original. The square root of 3x plus 2 minus 4 equal 1. And so wherever I see the variable, I'm going to substitute 23 thirds. So I get the square root of 3 times 23 thirds plus 2 minus 4, and I want to see if that's going to equal 1. Well, notice that the 3's divide out, so you can reduce the 3's, and you're left with the square root of 23 plus 2. And then whatever that is, you're going to subtract 4, and the question is that equal to 1? Well, what's 23 plus 2? Well, 25, right? So that's the square root of 25 minus 4. And what's the square root of 25? 5. And is 5 minus 4 equal to 1? Yes. All right, so that works. All right, next one. Notice that the square root's already by itself, so what's the next step? What's the square root by itself? How do you do this algebraically? Yes, you're going to raise both sides to the second power since my index is 2. So I'm going to go ahead and rewrite this over. So I get the square root of 2 minus 3x equal 3. So I'm going to square both sides. And the square and the square root undo each other. So you get 2 minus 3x equal 3 times 3 is 9. And so notice I went from a square root equation to a linear equation. So let's solve this linear equation. So I'm going to subtract 2 from both sides. And so I get, when I subtract 2 and combine like terms, that's 0. So I get negative 3x is equal to 7. And divide both sides by negative 3. Divide both sides by negative 3. I get x to be a negative 7 thirds. So that's my solution. So if I did this correct, that should be the solution. So let's check. Go back to the original, right here. So I get the square root of 2 minus 3x equal 3. So I see the variable x, I'm going to substitute negative 7 thirds. So I get the square root of 2 minus 3 times a negative 7 thirds, right? And I want to see if that's going to equal 3. Well, notice that 3's divide out. 3's divide out. Let me go ahead and rewrite this. 2 minus 3 times negative 7 thirds. The 3's divide out. Okay? But look at what you have. Now think about what you have. You have, in the radicand, you have 2 minus, now 1, that's a 1 right here. 1 times negative 7 is negative 7. So here's what you have. You have, let me go ahead and put that on another sheet of paper so I don't put that somewhere where it confuses you. So you have 2 subtract 1 times a negative 7. See, that's 1. So negative 7 over 1 is 1. So that becomes 2 minus a negative 7. But remember, you're subtracting, so you can always, when you have subtraction, you change that to addition. So this becomes 2 plus the opposite of negative 7, which is 7. So that becomes 9. So this right here is 9. So I get the square root of 9, and the question is that equal to 3? Yes, square root of 9 is equal to 3. So negative 7 thirds is a solution. Okay, the next one is the square root by itself? No. So the first thing you have to do is subtract 3. You must subtract 3 first. You must get the square root by itself. So I get the square root of, so I'm going to subtract 3. So I get the square root of 5x minus 4 equal 5. Okay, now the next step is to square both sides. I'm going to rewrite this over. So we're going to square both sides. And the square and the square root undo each other. So you get 5x minus 4 equal 25. So notice I went from a radical equation to a linear equation. So let's solve this linear equation. So I'm going to add 4 to both sides. So I get 5x equal 29. Divide both sides by 5. My solution, if I did this correct, my solution should be 29 fifths. All right, so let's check. Go back to the original. Always go back to the original. The square root of 5x minus 4 plus 3 equal 8. So wherever you see the variable x, you're going to substitute 29 fifths. So I get the square root of 5 times 29 fifths, right, plus 3, and we see that's equal to 8. Well, I forgot to put minus 4 in here, so minus 4. All right, so minus 4. All right, so the 5's divide out. So what's 1 times 29? 1, that's a 1. 1 times 29 is 29. 29 minus 4, right? So I get 20 square root of 29 minus 4 plus 3, and we'll see that's going to equal 8. Well, what's 29 minus 4? Well, 29 minus 4 is 25. So it becomes the square root of 25 plus 3. Square root of 25 is 5, and is 5 plus 3 equal to 8? Yes. Okay, so 29/5 is correct. So notice in part A, which is the easy kind, in part A, you have a radical equation. These radicals are square roots, and in part A, you're going from a square root equation to a linear in each case. All right, so that's only in part A that this is going to occur. So the other lessons is a little bit different, but the idea is the same. You're going to raise both sides. So when solving a radical equation, you raise both sides to get rid of the radical. You raise both sides to a power that's equal to the index. So notice that all these were square roots. So each time I squared both sides. Each time I squared both sides. And in these problems, only in these problems, in part A, I went from a square root equation to a linear, and I was easily able to find the solutions. And then we checked to verify those were correct. In future lessons, though, when you deal with square roots, when you deal with square root equations, whenever you raise both sides to an even power, in future lessons, you're going to see that there are times when one of your solutions or your solution is not correct, it is a false solution. So you can see what that's going to mean later on. So those will be called extraneous roots. You don't have to know that in this one. All right, so that's the key to 15.5 part A.